Alright, this is a demonstration of how fast a Teensy 3.2 can take analog reads. And I've got this little homemade oscilloscope I've been working on, and I keep track of the sample time. So this variable here, I can change my sample time. Right now I've got it set at 1,000, which 1,000 is 1,000 microseconds. So if we go down here to when it's triggered to run, I just use micros. Start time equals micros. Stop time equals start time plus sample time. Sample time was this variable up here that I changed that I can change. So, and that's how I get it to do just 1,000 microseconds. And while the micros is less than the stop time, then I'm constantly doing analog reads and putting them into an array I named a sample array with this variable x, and each time it puts it in the next category of the array. So, and that's how I do it. It's 1,000 microseconds, and it's going to take as many analog reads as it can in 1,000 microseconds. And then I got a variable to get that last number read when the while loop stops. So samples taken is the last number of x when the while loop stops. So it's an accurate representation of the number of analog reads that happen in 1,000 microseconds, which 1,000 microseconds is equal to 1 millisecond. So okay, I've got my frequency generator set on 10,000 hertz, 10 kilohertz, in a sine wave. So we're going to run it. We're going to start the sample. Now if I hit this button, it'll tell me how many samples were taken in that 1,000 microseconds. So 102 samples were taken in 1,000 microseconds. Now I can hit this button and it'll make it show me what happened. This high amount is a high number I use to tell me when the array is finished. I haven't quite fixed that up yet, but so yeah, 102 analog reads in 1,000 microseconds. And I was looking, and nobody on the internet was really saying how fast the Teensy any of the Teensies, how fast their analog to digital converter worked. So I looked up the Arduino's analog to digital converter, and it said that it could do an analog read in 100 microseconds. Well, we're doing them in 10 microseconds with this Teensy, so that's 10 times faster than an Arduino at taking analog reads. So we can take this up to, we can change our sample time to, let's just say 5 microseconds, which would be 5,000, or 5 milliseconds, which would be 5,000 microseconds. And let's get this guy up here. We'll have to flash it over because I haven't finished making a button for that or anything. Alright, that should have worked. So now we're taking a sample that is 5,000 microseconds long, and we've got to change this variable. We'll put about 2. That's just how long it stretches it out for my viewpoint. So let's run that. What we set at here, 10,000. We're going to have to go lower. So let's go down to 1,000 hertz. Let's go ahead and change it to a square wave. And now we'll hit start. Sample, amount of samples taken. So we have 508 samples taken in 5,000 microseconds. So every 10 microseconds it can do an analog read. And that's a square wave at 1,000 hertz. So that's how fast a Teensy can do analog reads. It can do one in about 10 microseconds. Alright guys, later.